Biswajit, I think you can start your session now.
Okay. Okay, is my screen visible?
Yes, your screen is visible.
Okay. So, thank you for inviting me, and good afternoon, everyone. So, I will be dealing in this topic like opportunities and innovation in agri-tech industries in India. Sorry. So, outline will be background study, life cycle of the agri product from farmer to consumer, key segments and opportunities in agri-tech industries, innovative solution and impact by AgNext. Since I am working in AgNext, so we have three type of categories. So I'll discuss at the end.
Biswajit, can you just show the first slide once?
Okay.
Okay, just. Okay, you can start now. You can go to the next slide.
Yeah. So, and finally, the key players in this domain who are playing, who have built huge means things in this domain in India. So I'll briefly discuss about this. So in background, more than half of Indian population depends on agriculture as a primary source of livelihood. The agriculture sector contributes around 20% to the national GDP. So currently, agriculture sector in India is mostly unorganized. Means people are not doing in regular fashion. So we have a huge opportunity to make it organized and to improve in different categories. Indian agtech sector has have got huge investment as well from different countries throughout the world. So we can see from the graph that India exports in all over world, and the rate is increasing. So from the left graph, we can see that in 2021, last 2021, around $400 billion exported in December. And where India is sending? So mostly US, UAE, China, Netherlands, Australia, and so on and so forth. So you can also see this report in this link. Whereas we can also see the investments in India in agri-tech industries. So it is also in increasing manner. And it is estimated that agriculture industry will be roughly $5 trillion industry in next 5 years. So the life cycle of the agri products from farmer to consumer is like we can separate in different parts, different segments, like from upstream to downstream. So like input supply for the farming, then pre-production, production, post-production, storage, transport, trading and marketing, processing, wholesale export, retail consumption, like this. So we can separate, we can distinguish who are associated in this domain in different area. Like firstly, agriculture finance and insurance technology, who are providing basically funding and insurance in farming. Then agriculture biotechnology and biomaterials, which will improve the quality of the produce, or the research and development for seeds, and the processing means manufacturing of the this what I can say, the farming. Then precision and digital agriculture technology, supply chain, then robotics and mechanism. Basically, it is also optimize the production. Supply chain technologies from upstreams, warehousing and logistics, supply chain technologies to downstream. So according to World Bank report 2021, so mainly we can see that share of investment goes to the downstream agtech industries. It is like 81%, and it is continuously increasing. And after that, precision agritech industries, AG infratech industries, like this. So there is huge opportunity in the lower portion also. Like no one is invested in this domain, and you can see that there is huge opportunities as well. Means in the throughout the life cycles, there is huge opportunities. So key segments and opportunities in agtech, I will discuss about this. So when farming is going on, so that should be sustainable. So sustainable agriculture in this domain. So key points will be reduce water consumption. So like Indian agri uses around 90% of Indian fresh water, which is unsustainable. So we have a scope of automated micro irrigation, like deep irrigation. Then avoid wastage of produce. So from the study, currently worth rupees 13 billion. It is actually 2/3 of our fruits and vegetable produce. So it is going to be it is wasting actually. So due to some reasons, I will discuss about that later. Then reduce pesticides and residue. So these precludes Indian produce to be exported to high value Western markets, and as a result, Indian remains marginal 2% of global agri industries. Although I have shown you that it is exporting day by day, it is increasing, but still it is in 2%. So what is the reason behind this? So basically we have to uh, we should not use the pesticides for farming. So going to the next topic, precision agriculture. So most Indian farmers depends on traditional process for making critical decisions, right? So precision agriculture techniques remove the guesswork by leveraging using some technologies, right? So drone and UAV for real-time monitoring of farm, enabling mapping, surveying, automated spraying. Like Indian government are also promoting this drone-based spraying. Right now they are also, I think, doing some subsidies and like this. So satellite and remote sensing techniques, which will provide a direct farmer advisory on yield estimation, early pest warning, etc. And government will also get the how much production will be uh, in this uh, in this season, and that kind of reporting we can directly get from the satellite image data. Robotics, in robotics domain, nutrition injection, harvesting, high precision weed removal, like using drone. So that can be done in robotics. Automated material handling. So there is this is required during the harvesting equipment, grain or food processors. Farm sensor and management, it is for efficient farming, like soil moisture detection, water and nutrition injection. So how much we know, how much moisture, how much water, nutrition is required for this particular crop, but we don't have the facility to measure that system regularly. So for that reason, so we need like this type of sensor and management system, so where we can get regularly or continuously we can monitor the soil health basically. And mobile camera we can use for identifying pest and nutrition deficiencies using means a camera based solution. So it can also be done by drone. So basically drone will capture images, and based on the images we can find out what are the health of the crop and so on. Hence, it is a strong potential raising yield, increasing profitability, and optimizing resource and environmental sustenance. So, next segment will be agri-biotech and food alternatives. So, farm yields in India across most commodities are significantly lower than global average. Yes. Hence, we need a strong presence of agtechs in this area, like agri-biotech. What it will do? Innovate agri chemicals, biological products, hybrid seeds, fortification, etc. So food alternatives will be biotech applied to food technology, plant-based protein, etc. Like protein is required, but what about in general protein maybe come from veg and non-veg, like animal protein and veg protein. But what happen when people are actually veg? So for that case, we need plant-based protein. So who will participate in this domain? So agri universities graduates can participate to become entrepreneurs in this domain. So because they have some expertise, so quickly they can do something to build this product. So we can also segment this domain using CEA, means controlled environment agriculture. CEA is the cultivation of plants in an indoor setting. So this market is still in infant stage, but it has a ability to grow the food almost anywhere, all year around. We can produce food in different season also by controlling required environment. We know the what are the parameters is required to produce this crop or produce this food, but like we can control that using in the different control system in a different manner in indoor system, like a greenhouse system and this. So nowadays there is also upcoming technologies like hydroponics. So in hydroponics you can grow almost everything in your mm, indoor house. And the vertical farming also coming in the market. So where you have a small area, but you can build you can produce your food and products into 10x. You can convert into 10x. Like AS Agri is one of the major company who is using this vertical farming for turmeric production, and they are claiming that so they will produce uh, in a small area with 10x turmeric production using this vertical farming. So we have produced our product, agriculture product, but what happened? So what happened? The warehouse and storage system. So let's see, tomato is produced huge, and farmers are not getting the price of the tomato, and they have to throw it out, and people are not actually buying the tomatoes. So they can hold the product, hold the produce, the tomato they have produced, and further later they can actually trade in at a higher price when they want. So they can delay their this trade. So in this domain, so solar powered micro storage and cooling system are coming. So like we can store our product and trade it later at higher price. So what can be done to decrease? So what are the opportunities here? So opportunities is like nowadays, if I install one solar powered micro storage system and cooling system, so I have to means the production cost or the purchasing cost around 2 or 3 lakhs for a small storage system, cooling system. So for normal farmers, it is quite difficult. So opportunities is like what can be done to decrease the manufacturing cost and running cost of this microcooling system, and the manufacturing of electronic components. So as you know, nowadays mostly we are dependent on other countries, so like China and others. So in this domain, there is huge opportunities for electronics and electrical domain. So we have produced and we have stored our product. We are capable to store our product. We can delay the trading. But what about the selling procedure, the trading procedure? Here also we have huge opportunities. So nowadays, what happened? Farmers are selling their products using conventional methods. So, like some big players are also coming in this domain, even government also. So like Ninja Cut is one of the leading brand, and Inam also. Inam is a government brand. So they are actually, Inam is listing the consumer product, and people can trade based on some quality, right? Means there will some criteria. So based on that criteria, I can select, I can purchase, because I don't know the what the product is. I can select from the from the image or video or quality parameters. So quality parameters might be the physical quality, like what are the color, what are the means shape, and it is good or like, and what are the chemical qualities also. Chemical qualities means, suppose I want to purchase some apple, and I want some certification that it has some nutrition values. So based on nutrition values, I will pay uh, the pay I will pay and I will purchase. So nowadays what happened actually, the price is decide based on what is the market values is going on. So based on, there is some minimal deviation. But if I say, so I will purchase your product, so based on some quality. So problem, where is the problem is that, so when farmers are coming to the market, so there is no rapid solution to get the quality parameter instantly. Like for chemical quality, so to measure the chemical quality, we have to send the samples to the lab, chemical lab, and they will do the chemical analysis. And after 1 and 2 days, they will send you back that these are the chemical parameters that you have sent the specimen. So in that way, so real-time trading is not possible. So there is also opportunity for rapid quality testing of the agri products. So in AgNext, so we are doing, we are actually, we have three type of solutions in IoT domain, IoT domain, I will discuss about that. So not only cooling systems, so we also have different systems, and physical quality solution for agri products and chemical quality solution for agri products. So it is like ninja card. It is like that this warehouse and storage system that I showed you. So this is actually our product like CoolNext. So what are the functionalities it has? So the storage temperature can vary 5 to 20 degrees centigrade. So it has some facilities like remotely you can control the all the things, the environment of the your of the in CoolNext. So it has actually built-in recommendation. Also, it has a built-in recommended temperature setting for all measure produced as per norms issued by Department of Horticulture. So basically, you have some cooling systems. So in that system, you want to store like tomato, and in other time you can store like other onion. So the controlling temperature will be different. So basically, you have to select all the recommended things. So it will automatically set all the things, all the parameters required, and adjust in your cooling system environment. Then you can control manually. Suppose it is not included in the list. But you know what temperature you can set. So you can control manually from the mobile app itself. So best thing is that continuously you can monitor the environment of the cold storage. So that might be temperature, humidity, and all the things. And in this way, so you can set the optimum things, optimum temperature, humidity in the cooling system, and save the energy when you don't want to actually on your cooling system. So you can save energy by off your cold storage remotely. And obviously there is another thing is that daily analysis. So what temperature fluctuation is going on, and humidity graph is that kind of report you can get it from the mobile app itself. So basically it is connected to the cloud, and from it will sync the environment data to the cloud, and cloud will send you back to the mobile app. So this is actually the quality solution, physical quality solution. So suppose you have farmers produce some maize or wheat, but what happen? When government is purchasing, so there is no transparency. So basically, based on who is working on in the field, based on the report, government will purchase all the things, and it is I- if who is involving in the purchasing, if he or she told that the quality of the wheat or maize is like so and so, so government have to trust on the word. But see, you can also these things can be automated. This can be digitized. Like from the samples, you can scan like a simple scanner, and from the AI algorithm, image processing algorithm, you can find out what are the physical quality of the samples, and based on this physical commodity, the physical parameters can be uploaded in the cloud, and based on these results, the administrative authorities administration can do the decision for purchasing this type of product. Like the physical quality can be built, disabled, and damaged. And this is actually physical quality. I told the physical quality how we can do that using image processing, but what happened, the chemical quality parameter, uh, that I told that if we find the chemical parameters, we have to send it to the lab, and the lab will send you back after 1 and 2 days. So basically, real time trading based on the quality, it is quite difficult for that case. But now we are using NIR technologies, and basically what happens, you have to just scan our the samples like this. So after that, within 3 to 4 minutes, you will get the all chemical parameters. Like here, you can see it is oil seeds like mustard seed. So basically, mustard seed payment is going on based on the oil content and moisture content in the oil seed. So oil content, basically it is the main parameters, because how much oil we can extract from the oil seed, and moisture is dependent based on due to the storage. So high moisture, basically, so you can you don't so basically the oil seeds will be degraded if it has high moisture values. So it is also important parameter. So based on important ones, like we are also working with some animal feed companies like Godrej Agravet. So what they will do? So they will produce some animal feeds, but what happened? They will also purchase some raw materials like maize, wheat, rice, that kind of thing, and all the commodities they are purchasing. So payment will go on based on the chemical parameters, because finally feed company will do the products, so to enhance to the required the chemical chemical parameters. So maize, they have to measure the moisture, protein, fiber, total ash, sand, silica, like this. So basically, for fiber, I can, if I say for fiber analysis, it requires around 6 hours, and for protein analysis around 7 to 8 hours. So to replace these things, conventional things, we are doing this NAR kind of NAR technology. Using this, we can measure, we can measure the chemical parameters within 3 to 4 minutes. All the 5 6 parameters for a single scan. In a single scan, we will get 5 to 6 parameters within 3 to 4 minutes. So here also huge opportunities. We can develop different technologies to measure all the things, uh, because actually in future the quality will be the main parameter for the trading. Like milk. Milk is huge. There is a huge consumption in milk in India. But what happened? Milk price depend on the fat content present in the milk. But what happened? People will mix the non-milk fat like refined oil, veg oil, like this in the milk. And nowadays it is very difficult to find out the non-milk fat in the milk. So the problem is that when milk procurement is going on, and the payment will done based on the fat content, but when the byproduct will be produced from the that adulterated milk, so the milk company will not get sufficient fat based on what they have actually purchased. So there will be some mismatch. Okay. Another thing is that there is some adulteration, like urea, sugar, uh, and soda is mixed in in the milk itself. So that adulteration can be checked, can be find out using this AI technology. So we are also doing that. But I'm showing this is one of the example. So key players and business models are like this. Various business models have emerged to tackle opportunities in the agriculture space. This can be categorized in 5 main brackets. Uh, Upstream market model, like these are some these are companies which are playing in this domain. Downstream farm to fork supply chain model, farming as a service model, like farmers don't have much land, so basically some companies are aggregate the land and produce this contract farming like that. And another thing is that IoT or big data lead innovation model. So these peoples are also working on in this domain. And finally, the engineering lead innovation model, and like these are the companies which are working in this domain. So yeah, thank you. If you have any question, please.
Okay, Biswajit, we have a great session with you. Just wait for a minute.
Sure.
Sharing your screen.
Okay.
So students, I have unmuted you. You can unmute yourself and ask to Dr. Biswajit Manna for your queries. Okay. So I can say one thing that we have learned so many things from this lecture session, like what are the opportunities for the electronics and electrical students, like the warehouse and storage system for agricultural industry, and there is a IoT domain where we are monitoring the food quality and some other things also there, like for harvesting we are using drone and UAV systems, and we are using satellite images also. So the science students also have a great opportunity in this field. I think Dr. Biswajit Manna have explained the opportunities in very well manner. So I want to give a thanks to Dr. Biswajit Manna from BP Poddar Institute of Management and Technology, and also want to give thanks to the students who are working for the last couple of days to make it a success, and also the coordinator of our Institute Innovation Cell, Dr. Surajit Mondal. I want to thanks to our coordinator for giving us the opportunity to arrange a session like this.
Can we have a group photo?
Yes, so I can. Yes, we can start our video. Then I can take the picture.
সুপ্রভাত, ভিডিও তো অন হচ্ছে না।
Also, Shubhapat, also please share participants' feedback form.
Yes, yes. I'll share the feedback form. Photo capture হয়েছে?
Have you given the permission to on the video?
Yes, yes, given.
I have given.
It is given.
But I don't know. I have. No. Okay, no problem.
So I can share the feedback form in this chat box, right?
Yes, yes, yes.
Okay. So is it can you switch off the video now?
Share the
Feedback form.
Feedback.
Yes. If you want to say something to our speaker, you can say. Yes, I have shared the feedback form. So please fill up the feedback form for the session, those who have joined this session today.
Probably it is better to give in the WhatsApp group also.
Okay, I'll share in the group as well. So, Sudhapati, if you can say something to our speaker, he's still now in the session.
Yes. Today our speaker is Dr. Biswajit Manna, right?
Yes.
And really, Mr. Biswajit, thank you so much for your wonderful presentation, for your lucid explanation. And I think our students as well as we also have benefited so much because he has given a clear idea regarding the, how to start the session, how to start your, startup, how to deal with that and how to collect the data, agricultural data. So I think this students have got a clear idea regarding this. So it is very helpful for students as well as for us. And thank you, Biswajit, so much.
Thank you, ma'am.
And
From 21st we have started our session from 21st to 26th. This is a long period, and students have given lots of effort for these 4 days. And I am thankful to Shuprabhat, and a special thanks to our cell coordinator, Professor Surojit Mondal. Thank you, Surojit. Surojit, are you there? I'm audible, Shuprabhat?
Yes, you are audible. I think Surojit
might be. So this is the end of session?
Yes. Thank you, Sudhapati, for coming to this session. Okay, thanks, Biswajit.
Thank you, Suprabhat.
For today.
And Biswajit, we are requesting you again to come here and to give the lecture session, and it will be better if you come in our offline, right?
Sure.
In offline situation, we will call Biswajit again. We will meet actually, not virtually. Yes. Okay, so we can leave.
Okay.
And students, you will give the feedback. Feedback form is here, and also sir has shared in our WhatsApp group, I think. Shuprabhat, have you shared it in the WhatsApp group?
Yes, I have shared in WhatsApp group.
Okay. Again, thanks, Biswajit Manna, for your lecture. Okay, thank you.
Okay.
Thank you, Dr. Manna.
Thank you.
Okay.
Bye
Bye for today.
So, Surojit, can we leave?
Sure.
Okay.